So this is a couple items I picked up on eBay. It was an ad that I just came across. I normally do, searches for things like vintage computer PCB, vintage computer kit, those kind of things. And these two items came up on my feed, and I took a look at them and put a watch on them. Didn't pay a whole lot of attention, and I believe the ad actually expired and they were relisted. And at some point I actually went in and drilled into the pictures and paid some attention. Again, there was no description of what they were beyond an Albia Electronics MAX-550 kit. Nothing that told us what they did, what they were for. Looking closer at the pictures, and I don't know if you can see this or not, I spotted that there was a bubble display from like a calculator in the kit here. So there's this little unit here that looks to be a bubble display, and there was a 40-pin dip, and I could read part of the number on it. It was LS7 something. And that kind of gave me a clue what this might be. And I went, I think it was $22, including shipping. I went ahead and bid and bought them both. A little bit spendy for what they are. But curiosity got the best of me about, what are these? What do they do? How old are they? Etc. I did some eBay searches, or not some eBay, some Google searches for Albia Electronics and for MAX-550, etc. and didn't find anything that really clued me in. So anyhow, these have got here. I've already opened up the bags on this bottom one here just so we can get the stuff out easier. And I thought we'd take a look a little closer to see what it is we've got here. So I have a guess what these are. I haven't actually looked yet. There's obviously a manual. There's a bag full of parts here. Oh wow, that foam is well adhered. Hopefully it hasn't dissolved the pins on the ICs, as happens with old foam. We've got a PCB with little bits of foam stuck to it. Oh, interesting, it's already got a diode installed. Why would there already be a diode installed? Factory mod, maybe? A little bag full of parts. The displays are what caught my eye. 1, 2, 3, 4, 5, 6. So only 6 positions have LEDs in them. I don't know if you can see down in there or not to see that. But there are only 6 position 7-segment displays. So there's nothing on this end down here and the 2 up here. So that's kind of disappointing. I were hoping they were the full 8 or 9 digits, but 6 is enough to actually do something with them. I could make a clock or something, but I was just curious about the displays. They're made in Korea. Looks like 21st week is 79, maybe. TIL 393. Stamped on there. Is that a TI logo? I guess there's a TI. I think there's a TI logo there. So it must be a Texas Instrument part. There's a 3579.545 kilohertz crystal, so 3.579 megahertz crystal. That's interesting. It's a nice old school crystal. Trimmer capacitor, switches, and just a bunch of parts from the era, transistors, and the IC is an LS7031. I guess, or is it a 7902A? Part of what caught my eye was the LSI here, large scale integration. I don't know if that was a manufacturer. I just know that LSI referred to the more denser logic that was being created at the time. Date code, 2nd week of 79. Certainly not the 31st week of 70. Date code of 30th week of 79. Can I see any others here? 22nd week of 79. So we've got a pretty good idea of when this is from. Let me look for some part numbers here. There's a 74 LS90, a 4511, an STB803 I have no clue what that is, a 14001, a 75497, a 4017, an LM350, it's hard to say, I can't exactly read it, a little op amp. So my guess, based on the few pieces I could see through the pictures on eBay, was this was a little frequency counter kit, and I stand by that. I have vague memories of the LS7031. Like, maybe I've encountered this chip before, being some kind of a counter display 7-segment driver. There's a vague memory there. Like I said, I couldn't read the part number initially. Yeah, this foam needs, the parts definitely need to come off of it. It is definitely disintegrating. What does it say on the board? If anything, Continental Specialties Corporation, copyright 79, solder side of the board, Rev C. There looks to be a trace cut there with that diode tacked in. Double-sided board, a little bit of corrosion. Actually, a lot of corrosion from the foam. Component side, Continental Specialties Corp. So why it's Albia Electronics and Continental Specialties, I don't know. Pretty typical PCB for the era. So let's go ahead and take a look in the manual and see what we've got. Range 30 kilohertz to 550 megahertz in 2 overlapping ranges. So it's definitely some kind of freak counter, 30 kilohertz to 50 and 20 megahertz to 550 megahertz. It's got a pretty high top end on it. There's got to be some pre-scaling someplace. Gate time 100 milliseconds, so it samples 10 times a second. Resolution is pretty lousy, 100 hertz under 50 megahertz, and 1 kilohertz under 550, above 20 to 550. Plus and minus 1 count plus time base error. And put characteristics mega ohm and 50 ohm for the higher frequencies. Yeah, 3.579 megahertz. That's a color burst crystal, right? 3.579.545. I believe that's a color burst crystal. I could be wrong. 6.1 magnified LED digits with anti-glare window. Decimal point indicates megahertz position and serves as power on. Zeros to the left if first non-zero digits are blank. So it does left blanking. Miniature phone jack, uses a 9-volt alkaline battery. So it's just a little tiny frequency counter kit. With your purchase of the MAX-550, you've acquired one of the most advanced, most versatile digital frequency counters available today. Thanks to the latest LSI integrated circuit technology and advanced engineering, the MAX-550 is a sensitive, highly accurate instrument, providing both precise, accurate frequency measurement and operating simplicity. Okay. That's interesting. You're going to measure 550 megahertz based on a color burst crystal as your base frequency. I don't know. That doesn't seem particularly accurate to me, but such is life. See, the main counter is a 40-pin LSI chip containing all the latches and registers to display a 6-digit BCD output. It also contains logic to drive a multiplex display, scan oscillator, and zero leading blinking. So yeah, it's a counter. I was right, a counter and 7-segment display driver all in one. Counters accumulate data and transfer it to the displays where they are multiplexed and driven. In some designs, each display would require its own 7-segment decoder driver, each decoder requiring a limiting resistor for each segment. Thus, 7 segments times 6 digits are 42 resistors and 6 decoder devices. In order to reduce the circuit complexity or circuitry cost, a multiplexing system is used. Yes, of course it is. Time-based accuracy is plus and minus 3 hertz at 1 megahertz. Time-based circuitry is voltage regulated to provide stability. Boy, these pages are stiff. How to assemble. Boy, is it worth assembling one of these? It's not like it's an instrument I'm ever going to use. So it's got some 1N4148s or 1N914s. I guess it can use either diode, regulator mounted components, or some resistors. Oh, regular, okay. Oh, vertically mounted. Oh, wonderful. It's got resistors that stand on end. Oh, isn't that lovely? Special component to be tack soldered is R27. Pretty much standard capacitors. There's a couple of mica, some electrolytics, some more diodes that are, again, 4148s or 914s. There's a FET transistor. I don't recognize the 3646, 4401, or 4403 transistors. Transistors may not have writing on them. Ooh, that's high quality. Unmarked transistors, thank you. Okay, so apparently they've tested the counter ahead of time. The LS90, I don't remember. One of these has got to be a prescaler. There's no way in my mind that chip can count that kind of speed. And the fact that it's got two ranges tends to also indicate to me that there's a there's a divider chain that acts as a prescaler. Uses a 78L05. There's an interconnect terminal between the display and the board. And dimes to donuts, it's going to be this guy. Soldered on there. If I can get it to line up with the display. Whatever position is mounted, dimes to donuts, that's how the display gets mounted. Resistor detail for the, or bend detail for the resistors and diodes. It's on 0.45 spacing, center to center. Well, the documentation seems decent. Installing tantalum caps. Q4, Q5 may have no markings. That really bothers me. Okay. Using the counter. 50 megahertz test. Set the RF generator frequency to 2 megahertz. Okay, that's a big hint right there. The megahertz decimal point, well, apply power to the RF generator and allow adequate time to stabilize. Okay, well, no, they're just considering the high megahertz radio frequency, which they are, but yeah, it's not meant to receive radio frequency communications. I just totally misinterpreted what that meant. Board layout and component locations, that seems to be done well enough. Oh, the interconnects, just as I guessed. The switch mountings has a guaranteed sensitivity input of 250 millivolts RMS from 50 megahertz to 500. So prescale input. The input is diode protected against short-term input overload. It's clamped about 5 volts, clamped to the power lines. Excessive input voltage may destroy the protection diodes. Of course it may. Prescaler input is 50 ohms. It can create standing waves, which may cause erratic readings. If it's connected to anything besides 50 ohms, so it really is a 50 ohm input, which is fine. Acceptable minimal range. Okay, it's just comments on the prescale unit. It doesn't actually. You can see measurements, calibration. There's a schematic on the back page. Oh, there's okay. Oh, this explains so much right here. Okay, 50 hertz input will read 0.5 on the display. It won't read 500. Hertz. It won't read 500. So it has a resolution of 100 hertz. It can read 0.1 for 100 hertz, 0.2 for 200 hertz. So at 500 hertz, that is a 1 kilohertz scale. It's a 1 kilohertz scale. It's a 1 kilohertz scale. It is a 1 kilohertz scale. It is a 1 kilohertz scale. No. So it really is a 1 kilohertz scale. Wow. So 45 megahertz would read 45000.0. So yeah, not super high res. Interesting. Yeah, I don't think I'm going to assemble one of these. Curiosity got the best of me. Where's the input? 550 megahertz input. That STB803 appears. Is it the prescaler? 55 megahertz out, 550 in. So it is a prescaler. It's a pretty high speed device to be able to divide by 10, 550 megahertz. That's an interesting part in its own right. It is, of course, capacitively coupled and clamped to the power rails, just like they said. It's using +5 to power it, so it's most likely a TTL compatible part. They've capacitively coupled the output. There's a 50 megahertz input, again capacitively coupled, clamped to the power rails, driving a MOSFET. Actually, it's double capacitively coupled. Driving a MOSFET, I assume for amplification, to the 7490. Wonder if it's the diode they added there that's dotted lined in the schematic. It directly drives the counter chip. There's a 4511 7-segment decoder and a 497 that looks to probably be a D123 4, 5, 6. Just a driver of some kind, maybe? It must be a driver because there's 6 outputs on the counter chip to enable each one of the displays. And there seems to be a driver device here, is my guessing what a 75 497 is. Well, it's a 75 series part. It's a driver of some kind. I guess to get enough current drive to drive the displays. It looks like 2 decimal points are used. There's 9-volt in, power switch, a 78L05 to produce +5A, and a 78L05 to produce +5B. So it is using 2 separate 5-volt power rails that are, they're not isolated, they share a common ground, but it should keep noise from feeding back through them. There's a 550 megahertz position and 50 megahertz. So at 550, what am I seeing here? There's a separate +5-volt C. Okay, this is for driving display pins. Higher current +5-volt A, B. There's B, there's A. So A is used to power the clock. There's the 3.579 megahertz crystal. There's an MM5369, which I assume is an oscillator or divider. Oh, interesting. That's kind of cool. So they take that color burst crystal, and apparently it gets divided to 60 hertz by the MM5569. That's kind of useful. That creates a time base for a clock. Divide by 10 of that would give me seconds. That's kind of cool. That might be actually a useful little part set there, because I've been wanting to build like a TTL clock. I've been thinking about it again, and normally I would use the 60 hertz line frequency to drive the clock, but if I did a battery backup, I could have a separate oscillator to help it keep time if the power was out. That's kind of cool. a neat little set of parts. I may pull those individual parts out and capture them separately, just to have them. A 4017 that's producing count, enable, strobe, and clear. Or clear, store, and enable. So clears it, enables count. When it's done counting, I guess it clocks store to latch to the displays. I'm still looking for plus 5C. Plus 5C are, those are not decimal point drivers. Anyhow, there it kind of is. It's kind of a short little video, a little bit of TTL and CMOS logic. An IC, I'm assuming from second week of 79. I have no idea what the A means on the timestamp, or the timestamp, just the date code. Timestamp, date code. There's another interesting word transposition for me. I'm pretty sure the company was called LSI back in the day. That's really minimal markings. The pins are kind of askew on it, but it said it was pre-tested. So they probably dropped it in a socket. I'm disappointed it's only 6 positions on the display. It is a TI display, however. So that's kind of neat. Anything else to talk to here? Everything else is pretty standard stuff. You know, at a minimum, I've got sortable new old stock parts here that can be, you know, sorted into my little parts bins. I don't know if there's $10 worth of parts here, probably not. But I knew buying it that, you know, I wasn't going to make money on it. It was just driven by, excuse me, in the end, curiosity. What is a MAX-550 kit? Is it a 550 megahertz frequency counter? Well, it's got a large LSI chip and a display, so some kind of something. Anything else to say here? Just lots of late 70s components. All very new old stock. Anything else to add here? I can't think of anything. If you'd like to see me build one of these, comment and let me know. I don't have a large desire to build one, but if people asked, I probably would. Plenty of room there to tape the crystal down and bend the leads. Board will need some work just because it's corroded from deteriorating foam. It's the equivalent of hot air surface leveled. I don't think it's just tin plate, although maybe it is. It may just be a tin plated board. Now it looks to me like it's got surface solder on it. Though anything's possible, I guess. Anyhow, if I done it again, said I'll wrap this one up and then not, I guess I'll wrap this one up. And if you enjoy these kind of videos, looking at just something random that I found, let me know. I kind of like doing this kind of archaeology. What was it? What is it? Anyhow, I'll see you in a future video. If you got this far, thank you.